Hi, this is example number 3 from section 12.6, and we are here talking about parabolic motion. As you see here, we have a skier that leaves the ground, no, he leaves the ramp with an initial velocity which is unknown, but we have the direction of that initial velocity, which is an angle of 25 degrees. So he flies through the sky, wherever, right, with a parabolic motion, and he hits the ground at B. B is located at 100 meters downslope, and we have that the ramp has a height of 4 meters. So we are asked to find the initial velocity. So the solution of this problem, so we have to remember that the only acceleration that we have in any projectile motion or parabolic motion is the gravity. So this is the gravity, and it's a constant. So when we have constant gravity only in the y direction, so if we draw our coordinate system right here in A, right, this is x and this is y, we see that the acceleration in x is equal to 0 and the acceleration in y is minus the gravity. So if we start with always our equations, that we know that velocity is the derivative of the position, and that the acceleration is the derivative, let me call it that, r, right, the derivative of the velocity, then we know that in x direction, right, by integration those expressions, we get that we integrate the acceleration, which is 0, and we get that the final velocity in x will be equals to the initial velocity in x. And if we integrate that again to respect to time to find the position, we get final position is equals to the initial position in x, right, plus the velocity x times time. And what about the y direction? We have that the final velocity will be the initial velocity. In this case, we do have gravity, right? And then that's our expression. And if we integrate that expression, we get that the final direction, well, I'm already having the x. So the final direction in y will be the initial position plus the velocity in y minus g times t squared over 2. So you probably know those expressions by heart, but I just wanted to make sure that if you don't know it by heart and you don't remember them, you can always get them by integration, right? So what are we given, and how can we use these expressions? So we want to find the initial velocity. That's what we are asked. So this is the initial velocity. So we want to find the initial velocity in x and y, but we have the direction. So those two variables are related. So how they are related? We know that the velocity in x will be equals to the velocity a that is given, right? Times in x we project our vector over the x direction, so we will be cosine of 25, and in y will be the velocity of a times sine, right, of 25. So we have these two components. What else do we have? Our coordinate system we located at the point where the skier jumped. So our initial position is 0. So this is 0 and this is 0. And we, as you see, and gravity is known because we know that the gravity is equals 9.81 meters over second squared for international system. So how much is the final position? That is also given because if you see our drawing, we know that this is my initial position and this is my final position. So I have to find this position right here and this position. As you see, well, the 100 starts, maybe the drawing is not so well drawn, but let me erase right here so that it's more clear. So my 100 lies right there. So this x will be that 100 projected, and what is that projection? We have to use this angle, let's call it phi, and as you see, this distance right here, which will be the final distance in x, right here, right? Being this the origin, right, will be 100 times the cosine of that angle, and that cosine is 4, which is the adjacent, right? 4 over 5, which is equals to 80 meters. What about the y? The y will be very similar, right? The y will be that one right here, but we have to add those 4. So what is the y right here? It will be that 100 times 3/5, 100 times 3/5, which is 60, plus those 4, and that will be a negative value. So finally, I can write here that my final x is equals to 80 meters, and my final y is negative 64 meters. So you see that? Is that those 4 and those 100 times 3/5. Okay, so we actually have that one too. So let's substitute. So we have two equations. So my equations is this one right here and this one right here. So I will plug those values right here, and I have 80. So this is my first equation. Let me call it first. Is 80 equals 0 times velocity in A, that's unknown, velocity A, cosine of 25 times t, right? And the other equation, this is my equation number 2, I have final position, which is 64, equals to velocity of A, which is the unknown, sine of 25 times t minus 9.81 over 2t squared. So I have a system with two equations with two unknowns. What are the unknowns? Velocity of A and t. So there is many ways to solve that that problem, but what I will do is just solve for t here and plug it over there. So I solve for t here. T will be 80 over VA cosine of 25, and then I will plug it into here, and that is 64 equals to VA sine of 25 times 80 over VA cosine of 25 minus 9.81 over 2, this is time will be 80 over VA cosine of 25. So here I have an expression with the only unknown is VA, and then I solve for that, solve for velocity of A, which is what I am asking to find, and I give the result is 1942. And the units are meters over second. This is the result that I was asked to find, and actually if I want to plug that into here and I find the time, I find that the time is equals to 4.54 seconds. So that means that this skier jumped the ramp with a velocity of 19.40 meters over second and hit the ground 4.54 seconds later.